Welcome grade 12s. It is Monday the 11th of May and we are continuing with 2D arrays today. Okay, I'm just going to minimize this. Okay, so last week we started with the 2D arrays and just defining what it is. If you need to recap arrays, then please go on the YouTube channel and look for grade 11 IT. I've started teaching arrays from the beginning to the grade 11s at this stage. Okay, so using loops to step through an array. Let me just see if I can get, I've lost my controls here somehow. Okay, it's fine. We will just carry on without it. While assigning values one by one can be useful, as you did in the chess game last week, it is more common to use a for loop or a for do loop to assign values to an array. The nested for do loop is the perfect control structure to scroll through a 2D array. The indices must stay within the declared boundaries or an out-of-bound error will occur. Okay, I'm just going to put the chat function on. Okay. Okay. So use the length function to ensure that the indices, remember indices are your first value to your last value, remain within the boundary. So if I look at this array here, I've got an array 1 to 7, then an array of 1 to 5, and also an array of 1 to 8. It doesn't just have to be two things. You can define as many arrays as you want in your code. Then what this one is going to do is find the length of A numbers, but just A numbers. So what it's going to do is that it will give you the first part, the 7. So output will be 7. If I look at A numbers assigned index 1, my output is going to be 5. We're going to look at this more clearly just now. And if I look at finding the length of array numbers 1, starting at position 1, I will have 8. Okay. Note how without indices, length returns the first upper boundary when the lower boundary is 1. So there we've got a 7, there we've got a 5, and there we have an 8. So I'm going to read that again. Note how without any indices, length returns the first upper bound. Okay, so 7, 5, and 8 are my upper bound. The 1 in each case is my lower bound. By fixing the first index, any number from 1 to 7 will work, giving the upper boundary of the second index, and so on. If a fourth index, say for example 1 to 12 was given, how will the length expression change to return its upper boundary? Again, my upper boundary will then be 12. Okay. Okay, let's take a look at an example of a nested for loop. Use a nested for do loop to assign the sum of the row and column numbers to each element of an array. So a good example of this that you can sit and play around with is try and do a times table. So if you've got a younger sibling or cousin or something that is struggling with their maths, you could write a little program for them to practice their times tables. So let's look at this. So array, remember we are using row call. I just want to see why I've lost my controls. I'm going to pause my sharing. Okay, let's try again to see, am I There we go, found my controls. Okay, so what I can do here, please remember that I'm going to try and write with the mouse. Row, yeah, and col. So when you're dealing with arrays, in especially 2D arrays, the first part is going to be my row, and the second part is going to be my column. Okay, so let's take a look here. A numbers array 1 to 3, that is my row, so 3 rows here starting at 2, okay, and my columns, column 1, column 2. And remember my variables that I'm going to use, I and j, think fish and chips, okay, so here 1 for I 1 to length of A numbers, do 2 for j 1 to length A numbers from index 1, so position 1, do the following. Then 3 A numbers I and j, assign it to, so whatever was in I, whatever was in j, you're going to assign to I and j. Okay, so this is basically what a 2D array is going to look like. I will have my rows, so row 2, 3, 4, and my columns here, column 1, column 2, or column A, column B. Okay, so to see how values are assigned to the array in this for loop, you can also trace use a trace table. Now, this is something that we are doing with grade 10s. Remember I said to you, in the final exam, you are going to get an algorithm. It's approximately 9 marks worth. It can be a trace table. It can be a UML diagram. It can be a pseudocode. It can be, there's a variety of algorithms. It is important that you go back to your grade 10 work. If you do not know how to do these, let me know and I will do a lesson again on trace tables to make sure that you're able to do it. The best way to do a trace table is actually to have your flow chart next to you, because you can number the flow chart and then your line numbers are going to make sense. Okay, so by stepping through the code bit by bit, it becomes easier to see how each element of the array is assigned a value. For the code snippet above that we just saw, add more rows to the trace table below and complete tracing through the nested for loop. Track the variables, so I would be 1, 2 is going to be j, okay, no, not 1, sorry. Line 1 is going to be I, line 2 will be j, okay, there I've assigned j to 1. Let's just go backtrack to see our code again. For I, 1 to length do, for j I said from position 1. 3 is going to be line 3 is the name of the array element, including my indices. So I'm saying from the first element from position 1. Okay, and then 4, if I carried on, with value of the array element. So it's really important that you are able to work through a trace table. Okay. Use the same nested loop pattern to extract or access data from the 2D array, sorry. So in this example, we are going to have 2 options. The first one is build a line of output and then when complete, add it to a memo. Note, the line is set to null. Remember, null is empty after adding to the memo. The second option would be build a single line which include line breaks and then add it to your memo. Okay, so here we've got 2 different examples. Well, the same example written in 2 different ways. Okay, so let's look. The first one goes for I assign 1 to length A numbers, and then I want you to do the following. So for J, so this is our nested loop. So my outer loop and my inner loop. 1 to length A numbers, index 1, so position 1, do the following. So take whatever was written in the line, plus remember this format, go to your grade 11 textbook and study opportunities to go and revise your fixed formats, okay? And it's format, and I'm looking for the index of I and J, and add it to my line and rewrite line. You are then going to say whatever was written in line will be displayed in my memo, and then very importantly, add an empty string afterwards. Okay. Or I can write it as follows. 1 to length A numbers do, so my outer loops are exactly the same. Then for J, 1 to length A numbers 1 do, then I'm going to have line plus whatever assigned to those positions, my row col. Okay. Then I'm going to have line plus S line break. Okay, so that could, you're going to use your ASCII code. So for example, #9, #10, #13. #9 is your tabs, #10, #13 is your next line, starting from the beginning of the next line. Okay, and then add it to your memo. Both these options would be correct, and this is what it would look like if it was displayed. Okay. Okay, so you're going to have this activity. I'm going to do some of them with you just to assist you. So I'm going to go out of my presentation. Okay. So now that you have seen how 2D arrays, what I'm actually going to do is I'm going to create an additional screen here with the question there for you. So let's just go back. Now that you have seen 2D arrays can be manipulated for nested for-do loops, create the following 2D arrays using a pen and paper. I'd like you to do it on a Word document for me, please. Include the variable declaration. So let's take a look at the first one. Okay, so I'm going to have here var A numbers. Just fix that. Declare my array, square bracket, so 1 to 6. And my next, that's my row, and my columns are going to be 1 to 10 of, what is the type? I'm working in integer. Okay. Then my second part is I need to declare my variables. And they are, remember, has to be exactly the same type. I have to have, I can't change my variables in between. Okay. Begin. And I start my for loop. So for I assign 1 to length A numbers do, and then I have my nested for loop. So this is my outer. So let's just write there, outer loop. And then for J, 1 to length A numbers. At this time, I'm saying my index 1 do. And what do I want it to do? A numbers, I, J, assign. So I times J. So basically what I would like here is, this is a typical example to do a multiplication table. So I want my row times my column. Okay, so an array containing the multiplication table for the first 6 numbers. I've said they're 1 to 6. And my times table, you could have made it there 12 because we work up to 12 when we do times tables. And I'm saying start from the first position, then I say there, take the value from the first, so 1 times 1, 1 times 2, 1 times 3, 1 times 4, and then work through my array and build it up to I have 10 times 6. Okay, so let's take a look at the next question. Make it a little smaller so it's easier to read. Okay, so this one says, write the code for an array containing the powers table for the first 10 numbers and 3 exponents. You can use the power function to do this. So how am I going to do this? The first part I need to do is I need to go and declare my variables. And I'm going to have a numbers, assign array, start my array. What's my row? My row is going to be 1 to 10. What's my column? It's going to be 1, 2, 3. So they're saying powers table, first 10 numbers. There's my first 10. Okay. And 3 exponents. They are my exponents. And what type? It is of integer. Okay. And then I need to declare my variables here. And I've got, they are also of type integer. Okay, and begin. So I start my for loop. For I, assign 1 to length, and it's going to be using a numbers, do. Then I start my, again, here's my outer loop. I'm now going to start the inner loop for j, assign 1 to length, a numbers, except this time I'm going to add my index, so position 1, do, and then what does I would like a numbers I, j. I'm going to assign. Now here is where I'm going to say power for my exponent. I'm using power I and j. Okay, so if I were to run this, then it is going to take the first 10 numbers and give me the 3 exponents. So position 1, 2, and 3. Okay, so 10 squared would be 100, and 10 cubed would be 1,000. Okay, great. Let's just see, where has the chat gone? We've lost our chat. Okay, I'm going to go back to our slide here. Okay. Uses of 2D arrays. Up to now, you have looked at very specific uses of 2D arrays, but these arrays are incredibly useful in a number of different situations. 2 of the most common general uses are when you need to store a few pieces of information about every item in a list, and when you need to store a grid of information. Okay, so let's just backtrack again. Give us examples of 2D arrays. I've said a multiple choice, a chess game, a parking lot, a movie theater, the seating arrangement, even in the exams, your final exams, you will be allocated a specific seat in a row and a column. So you will be in a specific position. So if I had to write a 2D array for the matrics final exams, then I would have to allocate how many matrics there are and then place them at specific places. Okay, so let's see here. Two of the most common general uses are when you need to store a few pieces of information about every item in a list, and secondly, when you need to store grid information. So let us take a look at a couple of examples. The application's username and passwords can be read using a 2D array. Now, imagine you are playing, say for example, Fortnite, and you design the program, but you want to store all the users, and you're not going to just have one or two users, you're going to have thousands of users, okay? So you need to be able to store somewhere their usernames and their passwords. Another example, the results of 2 tests and an exam for 500 students can be stored in a 500 by 3 array. Okay, so why would it be 500? So one for each mark, and so test 1, test 2, and exam. So that's your 3 columns. Okay. A list of a company's incomes, expenses, and balances can be stored in a 2D array. So you could, for those of you that do accounting, the balance sheet, that is a very good example of a 2D array. Okay. More uses. The multiplication table is a grid that can be stored. I really want you to try and design a multiplication table to practice your 2D arrays. It is the easiest way and something that you're used to using. Then the pixels of an image can be represented as a grid using a 2D array. Now, if you've gone to look up actual colors, you know it's based on red, green, and blue, your RGB. So those pixels will be allocated a specific name according on which row and which column it is in. Okay. Another one, how many of you play Sudoku? Okay, I used to play a lot of Sudoku. It's a nice way to challenge your brain if you just want to, if you're sitting and you don't have anything to do, but you just want to keep your brain active, go and get yourself a Sudoku book or find a Sudoku game on your phone. It is a very good game to get your thinking going. So basically how a Sudoku game works, I have a 3 by 3 table, and the numbers 1 to 9 have to be fitted into this row, but it mustn't cross, I mustn't repeat any numbers. Okay, these can be increased to, so I've got a 9 by 9, I can do a 16 by 16. You can make your Sudoku puzzle as big as you want to. So that is a very nice program for you. Also, if you're looking for ideas to play around with, go and write a Sudoku game for yourself. Start off with a simple 3 by 3, then you build it up and see if you can increase that. Another one, the 4 suits of cards containing 13 cards each can be stored in a 13 by 4 array. Okay, here's all good activities for you to go and play around with. Various board games where the board has a grid-like structure, battleship, checkers, chess, let's see. Go and think about what other games there are, board games. You guys did that in grade 10. So snakes and ladders. That's a very good example. Okay. Okay. So let's take a look here. So from the examples, you will see that a 2D array is suitable for modeling or storing most data in a table form. A 2D array can also be used to store the data of a CSV file. Now, a CSV file is something that can be read by Excel. So there you have the perfect example of 2D arrays. You've got your rows, 1 to 5 million, and your columns, A to Z, and then further AA, BB, CC. You can have as many columns as you like. So I can save my data in a CSV file. What's also nice is a text file will be able to read a CSV file. Okay, so if you are looking at something like that, maybe in your project, depending on what your activities are, you could have an additional screen or tab that is while you're waiting for your conference to start, or while you're waiting for your aeroplane, and have a little game on your pad. Okay, so here is an example of a Sudoku. So we've got 9 blocks, and how this works for those of you that haven't played Sudoku before, basically I cannot repeat a number in a column or in a row. So I have to try and work out to see which numbers will go where. And then the numbers are, your range is 1 to 9. Here is the example of the test and exams. So here I've got test 1, test 2, and the exam mark. That is also a 2D array. Okay, so here are just simple examples, practical examples for you to see what a 2D array looks like. Okay, your activity here, which you're going to do in a Word document for me, create the following 2D array and display their values in the first answer, the list answer component. So this is a list box over here. All the data, I have sent you a link on Google Classroom. I've shared the folder that has all the data for the DBE textbook. So please just go and look. This is chapter 3's data. You can find the data there. So make use of the tab space character #09 to display the values from the columns separately. So if you look back, we did a 6 by 6 multiplication table. Then I want a 9 by 9 table containing random values between 1 and 9. So a little hint there, think Sudoku for 3.4.2. A 10 by 5 table containing the sum of the indices. Okay, so if I add all my indices together, what would it be? And then a 7 by 5 table of randomly generated lowercase characters. Okay, so this one is a bit more tricky. See if you can do that one for me. That you will have to use your randomize or random function, and it's going to have to display different characters in each one. So think maybe even like a bingo game or something like that. Okay, so I think that is it for today. Great. Okay, so I hope that you are understanding 2D arrays. This is a very nice section. It is in your exam. The last question is based on 2D arrays and string grids, so it's extremely important that you understand this section. Okay, have a great day. I will see you all tomorrow.